Good morning, students. So we are studying about liquids and solids, right? So this is a very comprehensive slide. So you have learned 8 phenomena in change in state of matters. So solid change into liquid and vice versa. So if solid change into liquid, it is called melting, and reverse is freezing. So liquid to gas and gas to liquid is vaporization and condensation. Direct change of solid into a gas is sublimation, and reverse is deposition. And this is maybe a new thing for you. Gas to plasma and plasma to gas is ionization and deionization. So these are the phase changes. Solid state change into liquid, liquid into gas, gas into plasma. So why these changes occurs? Because we change the intermolecular forces. So mainly intermolecular forces are responsible. So you have learned how many types of intermolecular forces? Three. Mainly three. Which one? First one is? Ion dipole. Any other? Dipole. The last one? Yeah, London dispersion forces. Which one is the most weak force? Weak. London dispersion forces. And which forces only exist between non-polars? London dispersion forces. Right. And this forces also exist between all type of polar molecules and other atoms. So, okay. So we have also learned the intermolecular forces and also learned about the liquid, some properties of liquid, surface tension and viscosity. So surface tension and viscosity are the properties of the liquid. So they have related to the intermolecular forces. So due to surface tension, you have last lecture you have also learned about capillary action, right? So today we will learn about the vapor pressure and change of states. Vapor pressure is a very important term in terms of physical properties, because we learn about melting point, boiling point. The definition of melting point and boiling points are all related to the vapor pressures. Many other properties are linked with the vapor pressure. So what is the vapor pressure? Okay. Secondly, change of states. What is the meaning of change of states? So today mainly you will learn these two things. Okay, students, do you have idea of vaporization or evaporation? Have you earlier know about the vaporization or evaporation?
Vaporization is a liquid changing to gas, I suppose.
Yeah, good. So, but what is the difference between these two words? Vaporization. Because when your clothes are wet, you wash it, you spread it, next day it is dry. Okay? We say water is evaporated. So evaporation, evaporate and vaporization, these two terms scientifically, chemically, they are related to each other, but they are slightly different. Okay? So today you will learn these two terms. So vaporization and evaporation. Second thing, third, have you idea what is the mean by endothermic process? Any idea? According to thermodynamics, every reaction is either endothermic or exothermic. Because thermodynamics also give the information along with the chemical reaction or physical change, also give the information of heat. All reactions take place either evolve of heat or absorption of heat. So related to heat, you will learn endo and exothermic reactions. Today you also learn these two terms, endo and exothermic. It is related to heat. So every reaction, either heat is evolved or absorbed. So related to absorb, it is called endo. Plus, plus means add. Add, if we add the heat, enter the heat to the system. So you will also learn the system, surrounding, boundary. You have idea? System, surroundings, boundaries. Yeah, in thermodynamics we use this term, the system, to focus our main thing under observation. The part of the universe under observation is called system. So in this class today, this whiteboard is the system because all observing this one. But this is not the point of your concern. This matter frame. This is not interesting. Interesting is this one. Because here you get the information, all the lecture is here. So this is the boundary. And all the rest part of this class is the universe surrounding. Okay? System, boundary, and surrounding. Me, you, table, everything is a surrounding. On broad base, this university is also surrounding. You have no concern with this one. So you only observe this whiteboard. So system, when we have discussed any specific thing, we say system. Okay. So if the heat is added in the system, it is called endothermic reaction. If heat is evolved, minus means negative, means exit, revolve, emit, release from the system, it is called exothermic. Okay. So any reaction is either endothermic or exothermic. So they are related to heat. Okay. So you will also learn the endo-exothermic process, vaporization, evaporation. So first we watch a video to understand what is vaporization.
In a liquid, when the thermal motions of molecules overcome the intermolecular forces holding them together, the molecules break free and enter the gas state. This transition from liquid to gas is known as vaporization.
So first you learn change of liquid to gas is called vaporization. So vaporization is a broad term, okay? Further evaporation are they are subclass.
And can occur under two conditions, non-boiling or boiling.
So these are the conditions. Boiling means the non-boiling temperature and boiling means at boiling temperature. For example, if water evaporates at 100 degrees Celsius, this vaporization is called boiling vaporization. If it occurs at below 100 degrees Celsius, then this type of vaporization is called non-boiling vaporization. And its second name is evaporation.
Under the non-boiling condition, vaporization occurs only at the surface and below the liquid's boiling point.
So here are two main informations. This non-boiling vaporization, it is also called evaporation. Evaporation. It is a surface property. It only occurs at the surface. Secondly, it takes place below the boiling point. So below the boiling point. So boiling point is maybe 100 is here. So below the boiling point, it occurs at all temperatures. We cannot stop this phenomenon. You know, water evaporates even in the form of ice. When you take out the ice from the refrigerator, you can see the fumes. Still water is evaporated. So evaporation cannot be stopped. All the materials are evaporating at all conditions, even at low pressure or low temperature. So this is the surface property. Some of the surface molecules leaving the surface. Some molecules which have high kinetic energy. which break down or overcome the intermolecular forces. So they leave the surface. This is called evaporation.
This is called surface evaporation and occurs without the formation of vapor bubbles in the bulk liquid.
So here in this process, no bubbles are formed because it is a surface property. Only surface molecules leaves. No bubbles are formed inside the liquid. Okay, and it has no fixed temperature for evaporation. It occurs at any temperature.
In contrast, if vaporization occurs at the liquid's boiling point, vapor bubbles form in the bulk liquid, and the process is called boiling.
So second is at a boiling temperature. For example, if it is water, temperature is 100 degrees Celsius, then it is evaporating. It is a vaporization process. But now you can see the bubbles inside the liquids. Due to their low density, they are moving up. Bubbles have low density, so that's why they are coming up. So on the surface they pop up. And this evaporation take place at a fixed temperature, this one. So this is not the surface property, and this is called boiling. When bubbles are formed, the evaporation is maximum, and this temperature is called boiling temperature. This process is called boiling, and this phenomenon is called vaporization.
Boiling is not a surface phenomenon and occurs at all points inside the liquid. Vaporization is a temperature-dependent endothermic process. The greater the heat supplied, the higher the vaporization rate. The amount of energy required to vaporize 1 mole of a liquid is called its molar heat of vaporization, or if...
So today you also learn one more thing. Enthalpy, or heat of reaction, heat of anything. So in chemistry, if any process takes place, during that process, the total amount of heat absorbed or evolved is called enthalpy of that process or that reaction. If something is burning, that is called enthalpy of combustion. If something is formed in a solution form, that is called enthalpy of solution. Here, something is evaporating, it is called enthalpy of vaporization. So if acid-base react, this process is called neutralization. In this process, heat absorbed or evolved is called enthalpy of neutralization. Okay, but the name is here may be changed. Heat of neutralization or enthalpy of neutralization are same. It is always represented by delta. Delta means change. H means enthalpy. It is actually the heat. It is actually the heat at constant pressure. So it is a state function, capital H. So here we subscript write the name of the phenomena. In case of vaporization, we write VAP. In case of neutralization, we write NERN. In case of combustion, delta HC. In case of reaction, enthalpy of reaction, delta HR. So you can understand which type of enthalpy or heat. So this is thermodynamics term. Okay. So today we also learn this one. And generally, the amount of material is for enthalpy in except some phenomena. It is mostly 1 mole. The 1 mole of any substance is evaporated is called enthalpy of evaporation. Okay? Because if material is more, we have to provide more heat to evaporate. But standard is 1 mole. So N is most of the case, 99 is 1. Temperature, if these are the standard conditions. If these are STP, will you know what is STP? Standard temperature pressure conditions. So in chemistry we use the reaction is take place at STP. Standard temperature, temperature is room temperature or some maybe 0 degrees Celsius. So STP is 0 degrees Celsius. Pressure is 180. If any process take place at this condition, it is called STP. But some process cannot take place this one. So boiling point is not take place at 0, it is at 100. So in case of boiling point, we ignore this temperature. So sometimes we don't discuss the temperature, okay? But most of the temperature are STP, then it is called standard enthalpy. It is represented by naught. This naught means standard. This enthalpy is measured at standard conditions. Standard condition means 0 degrees Celsius and 1 atm pressure. So,
Its molar enthalpy of vaporization.
students, when the material is 1 mole, then its name is changed to be not enthalpy of vaporization, but it is called molar enthalpy of vaporization. Molar means for 1 mole, okay? Molar means 1 mole. Enthalpy means heat. And the vaporization is the process. So these three combined words can be written like this one: delta H vaporization. And if it is take place at STP, then we also use this term. This means temperature pressure condition. This means phenomena of vaporization, and this is enthalpy, and it is for 1 mole, so it is called molar enthalpy of vaporization.
As vaporization is an endothermic process, its enthalpy value is always positive.
So this is important because this is a term is for heat. So if heat absorbed by the system or evolved by the system, there are two possibilities. There is no third possibility. None of the reaction in which no heat is involved, no, not possible. Every chemical reaction, heat is involved. So I either absorb or evolve. So positive means
Absorb.
positive means and absorb, add. So add, absorb, both start with A. Add, absorb, and add plus means add. So in this process, heating, we have adding the heat to the system. This is system, this is surrounding. So heat is added to the system. So heat is, Q is going to be add. So any process in which heat is provided to the system to carry out the process is called endothermic, positive. So enthalpy sign is positive, it means heat is absorbed. Okay. So this is the endothermic reactions. Why? Why it is endothermic? Why it is not exothermic?
Because it need energy to break the bond, the intermolecular process.
Yes, right. Students, because evaporation takes place only when we break down the intermolecular forces. So for this purpose, we need energy. But system don't have enough energy. So we need externally. So we externally provide the energy in the form of heat. So that's why it is always endothermic, never exothermic.
Intermolecular forces influence the molar enthalpy of vaporization. For instance,
But there is only one material whose enthalpy of vaporization is negative. All the other materials has an endothermic is an endothermic process, evaporation. But another one material that evaporation process is exothermic.
due to
So maybe tomorrow I will discuss and you think about it and try to find out why and which material. Only one. So you will also learn one very important thing. In case of intermolecular forces. In your system, in your mind, intermolecular forces are always attractive. But last lecture you also learned some are also repulsive.
The strong network of hydrogen bonds between water molecules, 1 mole of water requires a substantial amount of heat energy, around 40.65 kilojoules, to transform into water vapor.
Students, what is mean by 1 mole of water? What is the mass of 1 mole of water? 18 gram. If 18 gram water, if you have to evaporate 18 gram water into vapors, so how much energy required? Almost around about 40 kilojoule. So this is a heat which is required to convert 1 mole of water into vapors. So this is a water. This is mean as physical state. This is a chemical name. This is its physical state. Chemically remain same, but physically change. So this process is evaporation, vaporization. Okay. If at 100 degrees Celsius. If below the 100, it is evaporation. If at boiling point, vaporization. Any other temperature, evaporation. But evaporation is also called vaporization, okay? Because vaporization is main term, it has two subclasses. So for this purpose, the delta H is negative or positive. So for this process, heat is add or absorb, evolve. Positive or negative?
Positive.
So we supply the energy or heat is released. Here is the heat. It goes inside the system. It means it is plus or minus? Plus. Plus means so it should be positive. Positive means endo. This is endothermic process. So its name is vaporization. So in thermodynamics, we write the reaction like this one. Along with the chemical reaction or physical reaction, we also provide the heat information. If we put here this word, what is mean by this one? Not means this is the degree sign. Standard conditions, STP, okay? Okay.
In comparison, the weaker dipole-dipole forces between acetone molecules can be overcome with merely 31.3 kilojoules per mole of heat energy.
So in case of acetone, energy is also positive, endothermic, but it is less. Why? Why it is less as compared to water?
Because the intermolecular process is weaker than.
Yeah, it means less heat of evaporation means less energy is required to evaporate 1 mole. It means its intermolecular forces are weaker, so they can be breakdown by using low energy.
The reverse of vaporization, that is the transition from gas to liquid, is called condensation. When gas molecules collide with cooler liquid or solid surfaces, they lose heat. Multiple collisions result in a significant loss of heat, and the molecules ultimately condense.
So evaporation is a surface property. Molecules high energy leave the surface. Condensation is the reverse. If gas molecule collide with the surface, intermolecular forces take place and it become a part of liquid again. So this is called condensation. And this is the reverse. If evaporation is endothermic, then condensation is exothermic. Okay? Again, heat cannot be created or destroyed. Law of conservation of energy. First law. So if the liquid change into vapors is evaporation or vaporization. The reverse is condensation. If same amount of energy is absorbed for evaporation, it means when condensation takes place, same amount of energy is released. Okay? So it is the same, but only the sign is changed. Okay? So this is also surface property.
Condensation is therefore an exothermic process. Although the enthalpy of condensation is negative, its magnitude is the same as the enthalpy of vaporization.
So this means the magnitude, irrespective of this direction. Only magnitude. Values are same, only directions are opposite. In this case, heat is absorbed. In this case, heat is evolved. Because law of conservation of energy.
When the opposing transitions, vaporization and condensation, occur in a closed system, the system reaches a state of dynamic equilibrium called the vapor-liquid equilibrium.
So next term is a vapor-liquid equilibrium. If the container or this cylinder or this beaker is here is the opening, so there is only evaporation, very less chance of condensation because vapors escape into the open air. So condensation is minimum. Only maybe some molecule collide here and maybe come back, but rare, negligible. But if we close this lid, close container, initially vaporizations is high rate, but when this surface becomes saturated with the vapors, it also start to collide with the surface and condensation also start. So both processes are take place in the container. Initially, which process is high? Evaporation or condensation is more? Initially.
Vaporization?
Yeah, evaporation is more, condensation is less. But with the passage of time, more and more vapors form, more condensation. So its rate increase at one time, both rate become equal. Okay. So then it is called equilibrium. This is called equilibrium. So I will discuss after this video in detail. So let's take the questions, then I will explain one by one in detail. So students, which of the following is the endothermic process? Number one, you have to say yes or no, okay? I will ask one by one. So, is the deposition endothermic process?
No.
Deposition is vapors into solid. No, okay. So last one, student. Vaporization is endothermic or exothermic process? Vaporization. You have to convert liquid into vapors. So you need provide energy or energy is released. Provide the energy. Provide the energy means endothermic or exothermic? Endothermic. Okay. So vaporization is endothermic. Okay. Freezing. If you freeze in the refrigerator, what is the function of the refrigerator? It provide the heat to the or extract the heat. So it is endothermic or exothermic? Exothermic. Freezing is exothermic process. So this is not the answer. Okay, condensation. So students, condensation. Condensation is exothermic process because when vapors change into liquid, heat is evolved. So answer is third, vaporization. Okay, this is the answer. Vaporization. Okay, which of the following has the lowest enthalpy of vaporization? Lowest enthalpy of vaporization means intermolecular forces are weak. So which has low intermolecular forces? They can easily evaporate. Less energy is required. So lowest enthalpy of vaporization is related to lowest intermolecular forces. So first one, chloroform, non-polar, glycerol. So it has polar, it contains OH. Glycerine or glycerol, it has three OH groups. Okay. Water, you know water, it is also polar. Ethanol, it is also like water, it has one H, OH. Water has two OH. Glycerol has three OH. Chloroform is only H. So chloroform is not so polar as compared to these ones. So it is. So answer is, which of the following has lowest enthalpy? Which one?
First one.
First one, chloroform. All the other has hydrogen bonding. Okay, so it cannot form hydrogen bonding. So it means its intermolecular forces are weak. Okay, right. So last one. Molar heat of vaporization is directly proportional to which of the following? So question is this one. So this is related directly proportional to vapor pressure. So actually this maybe I will explain it in next lecture, in the next slide. But I think you have an idea of what is the vapor pressure. Intermolecular forces. So intramolecular forces and surface area. So which is directly proportional to the molar heat of vaporization? So vapor pressure, intramolecular forces, intermolecular forces. Yeah, this is the answer. Good. So student, so you have a okay. So you have learned this one, vaporization, evaporation. Okay. So vaporization, evaporation. These are endothermic or exothermic? Endothermic process. Okay. So what is the evaporation or vaporization? Liquid change into gas or vapors. From this, if it is at the surface, then it is called evaporation. If it takes place through the whole liquid, it is called vaporization at boiling point. Okay. So did you learn about the enthalpy of vaporization? So let's try what is the definition of enthalpy of vaporization. Okay. So it means it is a heat. Okay. So this means heat. It may be endothermic or exothermic. For 1 mole substance. For 1 mole substance, where to where? Liquid change into vapors. So this is the definition. It is the amount of heat, because it is always positive. So we eliminate the other probability. Positive means it is always endothermic except one. So it is the amount of heat required. Positive means required at, which is provided to convert 1 mole of a liquid into 1 mole of liquid into vapors, is called enthalpy of vaporization. Students, its other name is heat of vaporization, or maybe you can also say molar, because we use 1 mole standard. Okay. So molar heat of vaporization, molar enthalpy of vaporization, are only enthalpy of vaporization or heat of vaporization. The meaning are same. So if the symbol not degree is here, then it becomes standard enthalpy of vaporization. Okay. So for water, it's 40.6 kilojoule per mole. In chemistry, the energy unit is always these ones, because in chemistry, the energy mainly related in the form of heat. So heat is expressed in kilojoule, and most of the per mole means for 1 mole. Okay. So this is the enthalpy of vaporization. What is the sign of this enthalpy of vaporization for water? Sign, symbol, positive or negative?
Positive.
Positive. Positive means
Endothermic.
endothermic process. Okay. So the condition is, so energy required to vaporize 1 mole of a liquid at this condition. So here pressure is not mentioned because it occurs at any temperature. So 1 atm pressure. Okay. So this is a symbol. Delta means change, H means enthalpy. So this is a change in enthalpy. You can also say molar in change in enthalpy. Okay. So this is a change in enthalpy. This is the phenomena of vaporization. So enthalpy of vaporization. So it depends upon two things: intermolecular forces and temperature. So what is the effect of temperature? So it occurs at all temperatures. Okay. So if temperature is high, okay, so enthalpy of vaporization is
It's lower.
lower. Okay. So enthalpy of vaporization is also temperature dependent. Very important thing. Keep in mind. So we have to provide less energy at high temperature. If solution is at high temperature, we need less energy to convert 1 mole into vapors. But if liquid is at low temperature, we need more energy, because at low temperature intermolecular forces are stronger. So we need more energy to break down. At high temperature, intermolecular forces are already weak. So now we need less energy to convert 1 mole. So how it is measured? Okay, so next term is the vapor pressure. So I explain this here. So student, so this is a beaker container. So this is the surface of the liquid. These are the surface molecules. These are inner molecules. Students, they have some intermolecular forces. And you know the surface is already in the tension due to surface tension, because inner molecules attract the surface molecules. So they have not enough energy to move or leave the surface. They have not enough energy. But at a given temperature, for example, room temperature, still at this temperature, out of this, some molecules, maybe 1% of the molecules, have very, very high energy. Okay? For example, there is a class of 100 students. If I take the exam, only few students will get very, very high grade, and very few students will get very, very low grade. Most of the students have intermediate grades. Okay. Similarly, in a system, in this air, all the gas molecules have not same velocity, not same kinetic energy. Similarly, in liquid, all the molecules not have the same kinetic energy, same speed. No, some are moving very fast, some are moving very slow. So only few molecules which have very high kinetic energy, if they come toward the surface, maybe they collide, some molecules are come to the surface, their kinetic energy is more than enough to break down the intermolecular forces. For example, here a one molecule come from here to here. Here near molecules attract but its kinetic energy is more than intermolecular forces. What happened? For example, these two markers are the, so for example, the positive and negative charge are magnet, north and south pole. If they are moving slowly, kinetic energy is less, for example. And intermolecular forces mean the magnetic forces are strong. What happens? They will pass away, pass through close to each other, or stick with each other.
Maybe stick with each other.
Because no magnetic force is more than kinetic energy. But if their kinetic energy is very fast, for example, here is the slope. If I bring together, they will attract each other and combine each other. Okay, stuck. But if their kinetic energy is fast, what happens? They will stuck or they will move continue.
Move continue.
Because here kinetic energy is more than magnetic force of attraction. So they will follow the higher force. So that's why here, if their kinetic energy is more than intermolecular force, they leave the surface. So this molecule leave the surface is called vapors or evaporate, and this is only occurs at the surface. So this is surface property, and only high energy molecules evaporate. So when, for example, in the system, if high energy molecules leave, the remaining molecule energy is increase or decrease?
Decrease.
Decrease. If remaining molecule kinetic energy is decreased, the temperature of the remaining system is increase or decrease? Decrease. So evaporation is a cooling process. When you are wet, sweating is produced to cool your body. So when you are wet, you feel cooling. Why? Because of evaporation. Okay? So vaporization or evaporation is a cooling process. The high energy molecules leave the system, remaining molecules kinetic energy is less, decrease. So average kinetic energy decrease, average temperature decrease, cooling process. So, but it is placed in the surrounding. What happens if its temperature drop to 24 degrees Celsius? But you know, heat flow from high temperature to low temperature. So heat will flow towards the system. And again its temperature become 25. Again some molecules gain more kinetic energy. Again some molecules leave the surface. So this process continuously, evaporation, cooling, heat transfer. So it also cools the surrounding. Okay? Ultimately it also cools the surrounding. Because heat is also utilized here. So its temperature is going to be down. So evaporation is a cooling process. Secondly, this is called evaporation if it takes place at any temperature below the boiling point. But if I close this container, if it is open, then vapors go, escape, dissipate. Condensation is minimum. But if I close it, what happens? The vapors molecules, their concentration is going to increase, they move randomly, collide with the walls, also collide with the surface. When they collide with the surface, the inner molecules, other molecules attract each other. It penetrates in the liquid. Either its kinetic energy is less or more, it is not rebound. Because no, both are in the same direction. Kinetic energy, the direction is also towards the liquid, and intermolecular forces are also downwards. So it becomes part of liquid again. This is called condensation. Initially, evaporation is a constant property. Evaporation is not dependent on the area. Sorry, evaporation depends upon the area. Okay. But their rate in this speaker remains same because surface remains same throughout the process. So evaporation is constant. But condensation, initially no condensation, when no vapors. But when some vapors are produced, some condensation also takes place. But as with the passage of time, concentration of vapors increase, and condensation is also increase. A stage will reach when rate of evaporation and rate of condensation become equal. A stage will reach when the rate of evaporation and condensation become equal. Then it is called equilibrium. This is called dynamic equilibrium. Okay? There are two types of equilibrium. Static equilibrium. So this is a static equilibrium. The object is static and equilibrium. This side force, left and right side force are balanced. But no, it is a dynamic equilibrium. It is also moving, but in equilibrium position. So here, this process is not stopped at this equilibrium. Vaporization become rate of vaporization become rate of condensation. It is not stopped after equilibrium, but both processes continue. So they are dynamic, but in equilibrium. Okay. So when these two rates become equal, both process doesn't stop, but the concentration of vapors remain constant. Why? The number of vapors formed, number of vapors condensed are same. So their concentration remains same. No, it is saturated. We cannot form no more vapors. If we measure the pressure at this condition by connecting a manometer or manometer, so pressure, here is the mercury column. Here, air is applying the pressure. So here, vapors and airs both are applying the pressure. So this level may be disturbed. So this distance is actually the measure of the vapor pressure. So this is the pressure of the vapors of this liquid at equilibrium condition. Equilibrium. So this is called the vapor pressure. This is called vapor pressure. So vapor pressure definition is the pressure. Here vapors collide on this mercury and push it down. Maybe we can apply some gauge here. So the pressure of the vapors at equilibrium is called vapor pressure, because it is become constant at that temperature, because both processes are same. No more vapors, no more pressure. Okay, so it is the maximum pressure of the vapors on the surface of the liquid at equilibrium. So this is the vapor pressure, very important term, because we can explain melting point, boiling point on the basis of vapor pressure. So students, here initially when this is a vacuum, for example here, so the first conical flask, here is the liquid only at the starting when time is 0. Consider here is a vacuum, no vapors, no gas. So this is the initial condition. But with the passage of time, they start evaporate, vapors form, vapors also start collide, condensation start. So when both rates become equal, it is called dynamic equilibrium. Dynamic means both processes continue, but they are in equilibrium. Okay. So this is the condition for vapor pressure. The liquid and vapor should be in dynamic equilibrium. It is spontaneous process, it will occur itself. You don't need to be. So look at this slide. Students, here is a definition, another term volatile. Some liquids are volatile, some are not. Water is not volatile. That's why we keep it in open container, because it does not evaporate so fast. But for example, acetone, ether, ethanol, we keep it in a tightly closed lid in the bottle, tightly closed bottle. Because if we keep it in the open air, open container, it will evaporate maybe within 1 hour, 2 hours. So term volatility means whose vapor pressure is very, very high. Intermolecular forces are less, weak. Good. Intermolecular forces are weak, and the vapor pressure is very, very high. So if vapor pressure is very high, it means more vapors form, very high speed. So it evaporates quickly. So that are called volatile. So vapor pressure is related to, vapor pressure is represented by P is pressure. This is means vapors. Vapor pressure is represented by PV. It is inversely proportional to intermolecular forces. More intermolecular forces, less vapor pressure. So please check this table. These are some molecules. These are their vapor pressure. SI unit, Pascal, or bar, or mmHg. So please check whose vapor pressure is very, very high. This is a Pascal and this is a kilopascal. So which liquid has high vapor pressure?
The last one.
Last one, oh, 220. So this is, what is the name? Can you read? Butane. Butane, 4 carbon, this one. Non-polar molecule. So its intermolecular forces are very weak. Vapor pressure is, this is low, vapor pressure is very high. Second, which of the molecule has the highest intermolecular forces or intramolecular forces?
The first one.
First one. But amazing is tungsten. Tungsten is a metal. It is used in incandescent filament of the bulb. In the bulb it was used previously. Now these are the fluorescent lights. Previously we used an incandescent light. When metal heat emit the light. So we used tungsten. Symbol is W. So this is a metal. It has metallic bond. Its intermolecular forces or intramolecular forces are very, very strong. So its vapor pressure is very, very less, but it is not so different. It should be very, very low, maybe 0.00001 Pascal. But it is 100. But look at this. These others vapor pressure are at 20 degrees Celsius. But this is at 3200 degrees Celsius. 3000 degrees Celsius. At high temperature, still its vapor pressure is very low. That is the reason it's used in the incandescent bulb. Because its vapor pressure is very, very low. It is stable metal. Other metals, they fuse. Their lifetime is very less. Because when we use in the bulb, so incandescent bulb are like this one. They have some filament like this is the point. So if other metals, their vapor pressure is very high, when current is flow, it becomes heat up, it emits the light, also heat, it becomes warm and it starts to evaporate. If it evaporates, then these filaments decompose, melt. So lifetime of this bulb is very, very less. But when we use the tungsten, its vapor pressure is very, very low, even at very high temperature. It means it is stable. So that's why we use the tungsten filament in the incandescent light bulb. So students, but vapor pressure, can we increase the vapor pressure? So we cannot.
Yes.
How?
Change the temperature.
Temperature. So it means water evaporate very low rate at room temperature. But if we heat up, evaporation become fast. So it means vapor pressure also depends upon temperature. Higher the temperature, higher the vapor pressure. So this is actually the relationship between. Is it depends upon surface area? For example, if this is one beaker, this is the other beaker. So its surface area is less, it means more evaporation. More evaporation means more vapors, more pressure. Here, less. So here area is more. Because it has surface property, so here surface is more vapors. More vapors means should be more pressure. Is it true? Think about it. Is vapor pressure depends upon area? Because vaporization depends upon area. Because when you wash your clothes, why you spread it? To increase the surface area. More evaporation. If you keep it in the like this cold form, then its area to evaporate liquid is less. But if you spread it properly, then more chance to leave the surface. So evaporation is depends upon the area. But vapor pressure, think about, but it is a closed container. So condensation is also take place. If surface area is increased, no doubt evaporation is increased, but condensation is also increased. So both remain balanced. They counter each other. So it means it does not depend upon area. So vapor pressure doesn't depend upon area. Because evaporation depends upon area. Condensation also depends upon area. If we increase the area, the evaporation increase, condensation also increase. Overall, they are again equilibrium, okay? So it does not depend upon area. So this is not. But vaporization depends upon intermolecular forces, temperature, area, vaporization, and condensation. So condensation, vaporization, they depend upon temperature. Higher temperature, higher the vaporization. Area is higher, higher the vaporization. Intermolecular forces are higher, evaporation is less. So you also understand the importance of tungsten. Why we use tungsten in the incandescent light bulb? Because their vapor pressure is very, very, very low, even at very, very high temperature. At room temperature, its vapor pressure is maybe 0.0000000 pascal. Very, very low. So I think this metal has very, very low vapor pressure. So students, in this diagram, if the rate of evaporation become equal to rate of condensation, this is called what equilibrium? Static equilibrium or dynamic equilibrium. After this equilibrium, evaporation stop. condensation stop or not?
Not.
Not. So it means they are in dynamic motions. So this equilibrium is called dynamic equilibrium. This equilibrium is called dynamic equilibrium. And pressure at this equilibrium is called vapor pressure. The pressure of the vapors at this condition is called vapor pressure. So students, here is the graph. So you see the rate of evaporation remain constant. Why? Because rate of vaporization, intermolecular forces, they remain same in the liquid. Temperature remains same of the liquid. Area remain the same. So evaporation remain the same. So rate of evaporation remain constant. But initially no vapors form, no collisions, no pressure. So no condensation. So condensation is low. As the number of evaporation, continued number of vapors are increased, the rate of condensation is also increased. What happened here? What happened here? The rate of evaporation and rate of condensation become equal. So at this time, we say this system is at okay, 1, 2, 1. Okay, 1, 2. So students, at this time it is called at which equilibrium? This system is at equilibrium, equal conditions. Okay, equilibrium. Okay, so this is the surface property. So you learn about the vaporization and vapor pressure. Okay. Any question related to this? Any question you have in the mind? So students, how we can measure the vapor pressure? So this is a mercury level, okay? So this is the barometer. This is the barometer. Simple. Today we have a very advanced instruments, but this is for just understanding, because you cannot understand without this. So this is a glass tube. Here is a vacuum. So this is a mercury. This is the metal mercury, which is exists in liquid form at room temperature. So air molecules strike, collide on the surface, apply pressure. So this liquid is rise in this tube due to air pressure. So it means when the air pressure and its weight become equal, then its rising is stopped. So at what height? So it is a scale. 1, 0, 10, 20, 100, 200, they are marked. So there is 760. So because millimeter. So how much mercury rise in this tube? 760 millimeter. So we have marked on this glass in millimeter. So in this case, mercury rise 760 millimeter. Who rise? Mercury. So it is called 760 mm mercury. So it means this height is a new unit of pressure. We say the air pressure is 760 millimeter mercury, mm mercury. So it means the 760 millimeter mercury weight and air pressures are the same force. Air pushed upward, the weight downwards. So they are balanced, so it stopped the rising. So this is called air pressure. So it means the air pressure 760 torque. It is also called torque. Okay. So 760 millimeter mercury is also called 1 torr. It is also called 1 atm. 1 atm. It is also called 10, 13, 25 Pascal. Okay, it is also called 1.013 something a bar. So it is equal to 14.7 pound per square inch psi. So these are different unit interconverted. 1 atm is air pressure. It is equal to 760 millimeter mercury. It is also the air pressure. In torr, it is same because this unit is very awkward, weird. So they are used in terms of torr. So in SI unit is Pascal. So this is 10, 13, 25. It is called Pascal. So bar, psi, pound per square inch. But the meaning is same. Everything is same. 1 atm means the air pressure. 760 mercury pressure means 1 atm. Okay. So students, if we have to measure the pressure, for example, here we put, for example, if you want vapor pressure of water, so you add water liquid here. What happens? It will evaporate. It will do the same thing here. When it collides, it exerts a pressure. Due to pressure, this mercury is going down because no two forces are applied on this mercury. One is air pressure, which push it up. Other is the vapors of this liquid, which pushing down. So its level is decreased from 762 downwards here. So this difference is called the vapor pressure. It means know what happened. Air pressure remains same, 760. Okay. External pressure remains same, 760. Mercury pressure is no decrease. Previously mercury level was 760. No, it is 736. It is decreased. So this difference from this one. This is the vapor pressure of this liquid. So mean this liquid has exerted this pressure. That's why mercury level is decreased. So if we add ethanol, more decrease, 65 bar. If we add ether, it is more volatile, more vapors, more collisions, more pressure. So level decrease to this one. So difference is 545 torr. So these are the method to measure the vapor pressure. So vapor pressure is always determined by subtracting 760 minus the mercury level. Okay. So this is a barometer. Okay. Very simple device you use measure the vapor pressure. Okay. Okay. So you have already learned the vapor pressure. Previously I write only three things, but now you understand vapor pressure is also related to temperature. High temperature, high vapor pressure. But it also depends upon intermolecular forces, molecular weight, size, number of atoms, boiling point, enthalpy of vaporization. If these are high, the vapor pressure is low. But all these factors are related to intermolecular forces because molecular weight related to intermolecular forces, size related to intermolecular forces, number of atoms in the molecules also related to intermolecular forces. If more number of atoms, more intermolecular forces, less evaporation, less vapor pressure. Okay. So boiling point, enthalpy of vaporization. If this is high, vapor pressure is low. So students, so answer this question. The association of molecule and water is due to the water molecule associate with each other due to surface tension viscosity or hydrogen bonding? Water molecule associate attach each other due to hydrogen bond. Okay. With the increase of a molecular mass of the liquid, molecular mass it increase, the viscosity
Increase.
no fact increase, decrease or none of these. If molecule size is increased, then intermolecular forces increase. So then more resistance to flow. Viscosity also increase. So it means answer is A. Which of the following liquid has maximum viscosity? So viscosity maximum means either its intermolecular forces are very strong or size is very large. So water, acetone, ethyl alcohol and glycerin. So glycerin, how many OH group are present here? Its size is also among all the other size is highest. Atomic mass is molecular mass is high. Number of OH group are high. More polar, more intermolecular forces. So this is the more viscous, highest viscosity. Thank you very much, students. So in this week I will upload assignment on the Canvas, okay, related to these topics. So keep watching.